The following two studies examine concepts of current astronomy and the architecture of the universe disclosed in the Urantia papers. The standard model of cosmology rests on Einstein's general relativity, on subsequent theoretical work, and on observations and measurements made from within the range of our instruments. As a model, it is a hypothetical explanation for observed data, inductive, revisable, built by researchers reasoning from instrument readings toward an account of what the data imply. The Urantia papers, on the other hand, disclose. They do not hypothesize. They describe a universe with a geographic center, space levels, an administered structure, and a force-energy economy. An account composed by beings who present themselves as knowing, offering calibrations for the researcher to work with. The studies that follow take the disclosed calibration data and develop a working model from it. Study 1. Einstein's equation. This is a question and answer study comparing Einstein's mass-energy equation with the energy equation disclosed in paper 42 of the Urantia Book, and naming the 1917 assumption that study 2 will examine. Question 1. What did E equals mc squared achieve, and what did 1917 add to Einstein's cosmology? In 1905, a 26-year-old patent examiner in Bern named Albert Einstein published 4 papers in a single year. The last contained 4 lines of mathematics that established the equivalence of mass and energy. E equals mc squared. The energy content of any mass equals that mass multiplied by the square of the speed of light. It is a compact, precise, and universal statement, valid in every reference frame, for every observer. It remains one of the most verified results in physics. 12 years later, in 1917, Einstein applied his completed general relativity to the universe as a whole. The field equations had refused to yield a static solution. They predicted a cosmos that must be expanding or contracting. The prevailing view held that the universe was fixed and eternal, and Einstein shared that view. To make the equations produce a static result, he introduced 2 things in that same paper. First, a simplifying assumption he called the Cosmological Principal, that the universe at large scales looks the same everywhere and in every direction, with no center and no preferred direction. Second, a mathematical term, the Greek letter lambda, the cosmological constant, added to the equations to counteract their dynamic tendency. When Hubble's 1929 observations confirmed that the universe is in fact expanding, vindicating what the equations had always predicted, Einstein withdrew lambda and called it his greatest blunder. The cosmological principle remained. It became the foundation of every subsequent standard cosmological model. The current standard model is called lambda CDM for its inclusion of a cosmological constant and cold dark matter. E equals mc squared survives to this day. It describes a precise relationship in the matter we can observe. The question it does not address is where the energy came from. That question is what the Urantia papers take up. Question 2. What does paper 42 say about energy, and how does its equation compare with Einstein's? Paper 42 of the Urantia book is titled Energy, Mind and Matter. Its opening statement establishes the paper's seminal character. The foundation of the universe is material in the sense that energy is the basis of all existence, and pure energy is controlled by the Universal Father. The paper addresses both manifestations of energy, mind as the non-mechanistic register in which creation is planned and administered, matter as the mechanistic register in which energy becomes observable. This study focuses on the energy to matter side, which is where Einstein's equation operates. Within paper 42, at section 4, paragraph 11, the energy equation is given. The first sentence, The increase of mass in matter is equal to the increase of energy divided by the square of the velocity of light. The second sentence. In a dynamic sense, the work which resting matter can perform is equal to the energy expended in bringing its parts together from paradise, minus the resistance of the forces overcome in transit and the attraction exerted by the parts of matter on one another. Some may read this passage as a confirmation of Einstein's equation. That reading is partly accurate and partly incomplete. The first sentence does touch the same territory as Einstein in different form. The second sentence moves into territory that Einstein's equation does not address at all. The two sentences together do something Einstein's equation does not attempt. Question 3. How do the two sentences differ from Einstein's equation, and what do they add? Einstein's equation is a static identity. Mass and energy are the same thing in different units, everywhere, always. Written symbolically, E equals mc squared. The first sentence of paper 42, section 4, paragraph 11, describes something different. Expressed symbolically, delta m equals delta E divided by c squared. The increase of mass equals the increase of energy divided by the square of the velocity of light. This is a dynamic relationship, a description of what happens when energy is added to a material system, not a universal equivalence. The papers affirm a deeper equivalence elsewhere in paper 11 where they say, all physical force, energy, and matter are one. That unity runs the full chain from mother force of space to organized atomic matter. The first sentence of 42.411 is situated at the bottom end of that chain, the place where Einstein's equation operates. The second sentence does something Einstein's equation never attempted. It names an origin and accounts for a journey. Expressed symbolically, W matter equals E paradise minus R transit minus A binding. W matter is the work resting matter can perform. E paradise is the energy expended in bringing the parts of matter together from paradise. R transit is the resistance of the forces overcome in transit. A binding is the mutual attraction exerted by the parts of matter on one another. Einstein's equation has no origin term. Energy and mass are interconvertible anywhere, with no reference to where the energy came from. The second sentence gives the equation a source, paradise, and an accounting of what was invested along the way. The investment was administered. Paper 42 identifies the orders of intelligent beings who carry out the transmutations at each stage: force organizers, power directors, power centers, and physical controllers who manage the final transmutation of the ultimaton into the circuits and revolutions of the electron. Modern physics recognizes nuclear binding energy as a correction to Einstein's base equation, but treats it as secondary. The papers build the full accounting into the foundational description. Question 4. What does the paper 42 equation disclose that Einstein's equation cannot reach? The two sentences together disclose that the universe has an economy. Force energy originates at a named source, descends through a sequence of transmutations managed by intelligent beings at each stage, and arrives at organized matter bearing the costs of the journey. That organized matter is the substance of material creation, the planets, the suns, the physical abodes of mortal life across the grand universe. The energy stored in any physical system represents what was invested from the paradise circuit, minus what was drawn off in transit and consumed in assembly. Einstein's equation describes the bottom of that chain accurately. It is locally valid, precisely verified, and silent about everything above it. No source, no journey, no agent. That silence is not a failure of Einstein's mathematics. It is the boundary of what the cosmological principle, as the framework within which modern cosmology operates, allows the equation to ask. The cosmological principle was introduced in 1917 under pressure from intractable mathematics not derived from observation. It remains an axiom, assumed but not confirmed. The revealed architecture of the Urantia papers offers something of a different kind: a named center, a specified structure, a force-energy economy with disclosed calibrations. The observable consequences of that disclosed architecture are what the second study in this report examines. I have again perpetrated something about gravitational theory which somewhat exposes me to the danger of being confined in a madhouse. Albert Einstein, in a letter to Paul Ehrenfest, early 1917, written on the occasion of his paper introducing the cosmological constant. Study 2, Astronomy's Anomalies. The first study in this series, Einstein's equation, examined what the Urantia papers disclose about the force-energy architecture of the cosmos: an absolute center, a named source for all energy and matter, a descent through administered transmutation stages, a breathing medium, a clock rate gradient anchored at eternity, and a force-energy economy managed by intelligent beings. The cosmological principle contained no provision for any of it. This second study places instrument data, the actual measurements made by telescopes and detectors, against that disclosed architecture. Each anomaly the Standard Model now carries is examined alongside the architectural feature the papers disclose that accounts for it. The anomalies are not isolated surprises. They share a common upstream cause. Question 1. How has the center of the cosmos been understood throughout history? For more than 1,000 years, the Ptolemaic system was the standard model of astronomy. It placed Earth at the center of the cosmos and described planetary motions as combinations of circles moving on other circles. Its mathematics was careful, its instruments precise, its astronomers genuinely skilled. The system predicted planetary positions well enough to keep calendars, guide navigation, and time religious observances across the Mediterranean and medieval Europe. As observations accumulated, Ptolemaic predictions began to drift from what the sky actually showed. The response was to add epicycles, additional circles superimposed on the main motions that brought calculations back into agreement with the data. When those corrections themselves failed, further refinements followed. By the 16th century, the system required dozens of epicycles to keep pace with the best available observations, each mathematically competent, each designed to save the appearances. When Copernicus proposed in 1543 that the Sun, rather than the Earth, was the center of planetary motion, the epicycles dissolved. What had required dozens of nested circles required instead a handful of ellipses. The patches disappeared because the upstream assumption had been corrected. This pattern is diagnostic. The mathematics of the Ptolemaic system was often superb. The center was what failed. The Copernican correction moved the center from Earth to the Sun. The cosmological principle, adopted in 1917, removed the center entirely. Each step was a centering decision. The current Standard Model's centering decision is the one this study examines. Question 2. What is the cosmological principle, and how does it produce the numbers astronomers use? The cosmological principle is the assumption that the universe, viewed at sufficiently large scale, is homogeneous, the same everywhere, and isotropic, the same in every direction. No location is special, no direction is preferred. There is no center. Einstein adopted this assumption in 1917 as a mathematical simplification. His field equations of general relativity are extremely difficult to solve for an entire universe. The cosmological principle made them solvable, allowing Einstein, Friedman, Lemaitre, Robertson, and Walker to reduce the full complexity of the field equations to a single metric, the FLRW metric, describing a uniformly expanding or contracting space. The assumption was not a measurement. It was adopted because without it, the mathematics did not yield a tractable solution. Einstein himself introduced the cosmological constant lambda in the same 1917 paper, attempting to force a static universe from equations that naturally predicted a dynamic one, a decision he later called his greatest blunder. From it, a derivation chain follows. The FLRW metric yields the Friedman equations. The Friedman equations produce the Hubble parameter, h0. From h0, every other derived quantity follows. Co-moving distances, look-back times, the 13.8 billion year age of the universe, and the density parameters that divide the total energy budget, hypothetically, into approximately 5% ordinary matter, 27% dark matter, and 68% dark energy. Every number in this chain depends on the one above it. Remove the axiom at the top, and the downstream numbers become indeterminate. Run backward, the same equation implies a singular moment of origin, the event the Standard Model names the Big Bang. Question 3. The Hubble tension. What does the disagreement in expansion rates disclose? The Hubble parameter, h0, describes the current rate at which the universe is expanding. Two independent methods of measuring it return different values, and the disagreement has persisted through decades of careful refinement. Measurements from the early universe, derived from fits to the cosmic microwave background using Friedman's equations, yield approximately 67 to 68 kilometers per second per megaparsec. Measurements from nearby galaxies using calibrated distance ladders built on the Cepheid variable stars and Type 1a supernova yield approximately 73 to 74 kilometers per second per megaparsec. The discrepancy is roughly 8 to 9%, well beyond the margin of measurement error. h0 sits in the middle of the derivation chain. When two independent paths to the same number disagree at this level, either one or both measurement chains carry a systematic error, or the framework that produced the chain requires revision. The architecture the papers disclose identifies the structural sources of error in redshift-based distance estimates directly, when it says, "This apparent speed of recession is not real. It results from numerous factors of error embracing angles of observation and other time-space distortions." The greatest single factor is architectural. The vast universes of outer space and the realms next to the domains of the 7 superuniverses seem to be revolving in a direction opposite to that of the grand universe. Counter-rotating space levels produce relative velocities between observer and observed that register as recession. Space respiration, the 2 billion year cycles of expansion and contraction that alter the tension of the medium through which light travels, compounds the distortion. These are not random errors. They are the expected signatures of a structured directional cosmos that the cosmological principle assumes does not exist. Question 4. The missing mass problem. What does the architecture of the papers offer in its place? Galaxy rotation curves measure how fast stars and gas orbit the center of a galaxy, as a function of distance from that center. Vera Rubin and Kent Forbes' observations in the 1970s and 1980s established that stars in the outer regions of spiral galaxies orbit at velocities that remain flat, roughly constant, far beyond where the visible mass of the galaxy would predict a decline. Gravitational lensing shows the same discrepancy. The bending of light passing near galaxy clusters exceeds what their visible mass can account for. Both are instrumentally confirmed measurements, independent of the cosmological principle. The Standard Model resolves the discrepancy by postulating dark matter, an invisible substance that exerts gravitational attraction but does not interact with light. The amount required is substantial, roughly 5 times the mass of all visible matter in the universe. Dark matter has been sought in underground detectors and particle accelerators for decades without confirmed detection. The papers describe 2 kinds of material gravity operating at different scales. The center and focal point of absolute material gravity is the Isle of Paradise. Local or linear gravity, by contrast, pertains to the electrical stage of energy or matter and operates wherever suitable materialization has taken place. Material that responds to absolute paradise gravity but has not yet reached the electronic stage of organization would exert gravitational influence without emitting or interacting with light, the observational signature attributed to dark matter. The papers also identify where the preponderance of mass in the cosmos resides. This central isle is the most gigantic organized body of cosmic reality in all the master universe. Surrounding Havona, the central universe of 1 billion perfect spheres, are the dark gravity bodies, named in the papers for their gravitational character. Owing to the enormous encircling masses of the dark gravity bodies about the fringe of the central universe, the mass content of this central creation is far in excess the total known mass of all 7 sectors of the grand universe. The center of the architecture holds mass at a scale the Standard Model has no category for, precisely because the Standard Model has no center. Question 5. The accelerating expansion problem. What structural feature replaces dark energy? Observations of Type 1a supernova in the late 1990s established that the expansion of the universe is accelerating, increasing in speed rather than slowing under gravity, as standard models had predicted. Within the FLRW framework, this acceleration requires a repulsive energy component. The Standard Model names it dark energy, assigns it approximately 68% of the total energy budget, and has not detected it. Together with dark matter, the 2 undetected components account for approximately 95% of the universe's total energy content in the Standard Model, leaving roughly 5% for the matter that instruments have actually measured. What the papers disclose in its place is structural. The semi-quiet zones between space levels are permanent features of enormous scale. Such an arrangement exerts anti-gravity influence and acts as a brake upon otherwise dangerous velocities. The Standard Model requires a repulsive energy because it has no architectural category for large-scale anti-gravity. The disclosed architecture names exactly this category as a feature of the spatial structure, not a postulated energy with no laboratory analog, but a disclosed property of the boundaries between organized base levels. Question 6. The cosmic microwave background anomalies. What does the preferred direction disclose? The cosmic microwave background is a nearly uniform microwave radiation detected across the sky, interpreted in the Standard Model as the thermal afterglow of the early universe. Its temperature map is the most precise instrument test of the Cosmological Principal's isotropy requirement. At the precision achieved by the WMAP and Planck missions, the map shows features the Cosmological Principal does not predict. The quadrupole and the octupole moments of the temperature distribution, large-scale patterns that should point in random directions across an isotropic sky, show a statistically significant alignment with each other and with the elliptical plane. This alignment, sometimes called the axis of evil in literature, points in a preferred direction. An isotropic universe produces no preferred direction. Additionally, direct isotropy tests using large catalogs of distant radio sources and quasars have returned statistically significant departures from the cosmological principal's prediction at levels several standard deviations beyond expectation. The anomalies are features of the data. Question 7. The early galaxy problem. How does the revealed cosmology reframe it? Beginning in 1922, the James Webb Space Telescope detected galaxies at high redshifts, displaying characteristics previously associated with much later cosmic epochs: mature stellar populations, organized disk structures, established metallicity, and masses requiring substantial prior star formation history. A landmark paper by Lebet and colleagues, published in Nature in 2023, reported candidate massive galaxies at redshifts near Z=9, with stellar masses comparable to the Milky Way, observed when the universe was, according to the standard timeline, less than 700 million years old. The standard model assigns the universe an age of 13.8 billion years. The age the Big Bang timeline derives from the cosmological principal chain. Within that timeline, 300 million years is insufficient for stars to form, cycle through nuclear fuel, explode as supernova, seed the interstellar medium with heavy elements, and allow subsequent stellar generations to incorporate those elements. The observations are spectroscopically confirmed. The impossibility is a feature of the model's timeline, not of the cosmos. The disclosed timescale is of a different order. The trillions upon trillions of years that an ordinary sun will continue to give out heat and light well illustrates the vast store of energy which each unit of matter contains. Our own sun, described as having long since attained relative equilibrium at 6 billion years of age, will shine on as of present efficiency for more than 25 billion years. It is not stated whether efficiency will improve when the pulsations have minimized and the superuniverse organization matures. Regardless, this ordinary mid-sized star's disclosed efficient period already exceeds the standard model's age for the entire universe. In a cosmology with timescales of this order, mature galaxies at great distances are expected. The assumption produced the impossibility. The instrument data did not. Question 8. What correction does the cosmological principle still await? The Ptolemaic parallel this study opened with is now complete. The mathematics of the standard model is careful, its instruments precise, its observations instrumentally confirmed. The upstream assumption is the unverified one. When the axiom of no center is replaced by the disclosed center at paradise, placed at the top of the derivation chain, the anomalies the standard model now carries no longer require invisible components and unverified parameters to save the appearances. The Hubble tension, the missing mass, the accelerating expansion, the directional anomalies in the cosmic microwave background, the impossibly early galaxies, each finds a structural account in the disclosed architecture. The pattern that required epicycles dissolves when the center is corrected. Ptolemy placed Earth at the center. Copernicus moved the center to the sun. Einstein's cosmological principle removed the center entirely, a mathematical necessity that became the foundation of every standard model that followed. The Urantia papers disclose a cosmos with a center, paradise, stationary, absolute, the geographic origin of all force energy in the material creation. Closing. The two studies in this report establish the diagnostic and the framework. The anomalies accumulating in the standard model trace to a single upstream assumption, the absence of a center. The architecture the Urantia papers disclose accounts for each anomaly without adding invisible components, adjusting parameters, or abandoning the observations. The instrument data stands. What changes is the center. What remains is the constructive case, placing the disclosed architecture against what the instruments can actually measure and allowing the calibrations to to close on numbers. Future studies include the location of Paradise Isle, Andromeda's anomalies, a revealed cosmic ladder, the universe energy economy, anti-gravitational lensing, and the Fermi bubbles. The Urantia papers describe a cosmos with a center, a direction, an architecture, and an economy. These studies are the beginning of working with what has been disclosed.